Hello students. Today we are going to take a topic that is called as in friction. There is a topic where most of the students will feel a trouble with this, that is block on block problems. The problems will look something like this, where there will be a block that is present. On that another block will be present. There will be friction between these two and force will be applied on one block. Both the blocks will move and he will be asking with what acceleration. Let us suppose this is m2, this is m1. What is the maximum acceleration with which these both blocks can move, or how much maximum force I can apply so that these both blocks can move together? Or he might also ask after which force, what maximum force the blocks will separate. So these are the questions that might be asked. That is called as block on block problems. Okay, there might be friction here, there will be friction here. So anywhere you can take, the friction will be present. So according to the questions, we have to do these problems. Okay. Now let us take, first let us understand friction. Okay, I'll be coming from basics. First, let us understand how friction works. So what is friction? Friction is a contact force. Friction is a contact force which opposes relative motion between two bodies, which will oppose relative motion between two bodies. Okay, this is what friction is. Friction is a contact force which opposes relative motion between two bodies. So the mathematical formula of it, friction is equals to mu into n, where mu is the coefficient of friction. Now, the types of frictions that we have are, one is called as static friction and one is limiting friction. We have, sorry, kinetic friction. One is static friction and one is kinetic friction. We have two types of friction. Let us understand what is kinetic friction. So I'll just briefly explain you how static friction acts and how kinetic friction acts. So then we will see. First, let us understand what is static friction. So static friction will be like, for example, there is a body. This is a self-adjusting force. This is a self-adjusting force. Okay. This will have a maximum value. After this maximum value, you are going to see the body will move. Let us suppose there is a force that is present on the body and there is some kind of friction. Okay. The body is not yet moving. Fine. They will give you mu s value will be given. Let us assume some 0.6 or 0.7, something has been given. Now, what is this mu s? It is called as coefficient of static friction. It is called as coefficient of static friction. Yes. Now, this block weight is, let us assume, some 10 kg. Okay. So when I draw the FBD, MVG downwards and normal reaction upwards, friction will be acting in backwards. So friction is equals to mu into normal reaction. Okay. So the static friction I'm going to calculate, that is 0.6 into the normal reaction is equals to mg, which is nothing but 100. That is nothing but 0.6 into 100. That would give me 16 Newton. That means this body will move only if you apply 16 Newton force or more. Okay, that's what this means. So if you apply 16 Newtons or more than 16 Newtons, then only this body is going to move. Till then, this body is not going to move. So we will call this 16 Newton, whatever friction is present, which we have got when we multiplied the static friction and the normal reaction. This is called as limiting friction. This is called as limiting friction. So limiting friction, if at all it is more than limiting friction, the body is going to move forward. If not, no. Okay. I hope you understood this. Now, what will happen if I am putting less than limiting friction? Lesser than, like, for example, I have put 15.9 Newton. What will happen? Will the body move? No. If the body is not moving, according to Newton, how much force is present backwards? I have placed 59 Newton. The body is not moving. That means on the back side, it would be 59 Newton. Okay. So you have to understand this concept. So static friction has got a limit. Static friction has got a limit. Limit is nothing but it is called as limiting friction. This you can calculate by using mu s into normal reaction. Only limiting friction you can calculate using mu s into normal reaction. If your applied force is greater than this limiting friction, then only your body moves. Okay, then only the body moves. If your applied force is less than limiting friction, then body doesn't move. Okay, I hope it's clear. When this case is there, if anyone asks you what is the static friction that is present, you should say that is nothing but applied force only. Yes, fine. I hope you understood now. If it is 58 Newton, then friction would be 58. Friction also be 58. That is why it is called as self-adjusting force. If it is 50 Newtons, friction will also be 15 Newtons, such that there is no motion between the motion in the block. I hope you understood. Then we will learn about next friction is kinetic friction. Whenever your applied force is more than, like in this case, we have seen the limiting friction, F limiting was 60 Newton. If you are applying any force like 62 Newtons, like applied force is more than the limiting friction. Now friction cannot stop this body. Now what will happen? The body starts moving. Now the body doesn't have any time to make the contact. So the friction force, whatever will be present, that will be less than the limiting friction. Friction force. Now, when the body is moving in this direction, this friction is called as kinetic friction, which will be lesser than the limiting friction. Like it would be somewhere around, it will have its own mu value, mu k into normal reaction. And this is a constant value. Let us take, I will give you an example. Mu k is equals to, let us take it as 5 and the block is 10. So friction is equals to 0.5 into normal reaction is 100. That is nothing but 50 Newton is my kinetic friction. And this friction would be a constant value how much ever you increase the applied force. Even if you applied 100 Newton force, the kinetic friction is not going to change. It will be 50 Newton. I hope you understood the difference between static friction, limiting friction, and kinetic friction. Static friction is present when the body is not moving. It is exactly equal to applied force. When the body is not moving, it is exactly equal to applied force. How will we find out? First, we will find out the limiting friction. Then we will understand whether the body is moving or not. If the body is not moving, that means static friction is coming into picture. It is equals to how much applied force you have put. Limiting friction, how will we know? We will multiply mu static into normal reaction. When we multiply this, we are going to get a value that is called as limiting friction. Then this limiting friction is there. This will tell you whether the body is moving or not. Now, F kinetic, if I take this, this means whenever the body is moving, that means your applied force is more than the limiting friction. Then we have got this, and this would be a constant value. I hope you understood the difference between these three forces. Let us now draw the same block of 10 kg. Let us take which frictions are present. Okay. So normal reaction upwards. I'm giving mu s is equals to 0.6, mu k is equals to 0.5, and there is a force that is applied that is of 60 Newton, or let us take 59 Newtons. First, you should tell what is the friction that is present and what is the acceleration that is present. Whenever a question comes like this, First, you have to understand whether the body is moving or not. If the body is moving, I should put kinetic friction. If the body is not moving, I should put static friction. First, to understand whether the body is moving or not, we have to use limiting friction. Limiting friction is equals to mu static into normal reaction. Mu static is 0.6 and normal reaction is equals to 100, which is mg. Normal is equals to mg. So it is 100. That would give me 60 Newton. Then I will compare this 60 Newton with this 59 Newton. So 59 applied force is less than the limiting friction. That means friction is not broken. If friction is not broken, the body doesn't move. If the body doesn't move, that means the friction that is applied is static friction. So friction static is equals to applied force, which is how much? 59 Newton. This is also 59 Newton. So the static force, static friction that is present inside the body is 59 Newton. If at all you have put, if at all you are not understanding and you have put 60 Newton, let us assume like with a wrong concept and you have put 60 Newton behind, what will happen? The body has to slide backwards. Yes, because the force is more here. The body has to slide backwards. It will not happen. So body will not slide backwards. So friction is now adjusted to 59 Newton so that the body will not move anywhere. This is the case. Now what happened? You slowly increased it to, let us assume, some 100 or 70 Newtons. Let us take 70 Newtons. Now what will happen? Whenever, now again, we have to find the limiting friction first. Why we should find the limiting friction? We should understand whether the body is moving or not. Yes, the body is moving because the applied force, it is 70 Newtons. 70 Newton is greater than 60 Newton. So the friction has been broken and the body is in motion now. Now which friction comes into picture? Now kinetic friction comes into picture. How much is the kinetic friction? 0.5 into normal reaction. 0.5 into normal reaction is 100. That means 50 Newton is the friction force that is present. Now what will happen? Backside, we have got 50 Newton force. On the forward side, we have got 70 Newton force. Okay. Now what will happen? So the acceleration in the body, the net force in the body is 70 minus 50, which is equals to 10 into A. 70 minus 50 is 20, which is equals to 10A. This and this gets cancelled. Acceleration in the body is equals to how much? 2 meter per second square. I hope you understood this. So this is how we are going to calculate acceleration in the block. I hope you understood. So friction, kinetic friction should be used only when the applied force is more than limiting friction. Okay. What if my force is 100 Newton? Then what will happen? Again, you have to check with the limiting friction. Yes, it is more than limiting friction. It will move. Now, the force in the right side is 100 and kinetic friction is not going to change. How much ever applied force you put, the kinetic friction will be always 50 Newton only. So 100 minus 50 is equals to 10 into A. 100 minus 50 is 50 is equals to 10A. The acceleration in this block is 5 meter per second square. I hope you understood this difference between static friction, limiting friction, and kinetic friction. Once you understand this, then we can move forward with our questions, that is block on block type questions. Block on block type questions. Okay, this is one block. This is another block. And this is my flow. Now, how many surfaces can you see? So there are total 3 surfaces. This is, let us suppose, M1 block. This is M2 block. This is one surface. Yes. And this is second surface. So there are 2 surfaces. You can have 2 different kinds of frictions. Okay. Now, let us suppose this has got some mu value, mu, and this also has some mu value. Okay. How to do these questions? Now, let us understand. Let us assume we have force on this block. We have force on this block only. Okay. Then what will happen? Let us draw the FPD for only M1. Let us draw FPD for M1. Whenever I put FPD for M1, this is my force and the friction will always try to stop my body. So friction will act in this way. The normal reaction is upwards and mg downwards, and that is m1g downwards. Okay, so this is how my body will be moving m1. Now, how m2 will move? M2 will move only because of friction. That's all. M2 is the block. There is no applied force on M2. Force is applied only on M1. M2 will move only because of friction. So the friction which was applied here, it would be in this direction. The friction as the block M1 is moving forward, it wants to move forward. This block M2 wants to move backward. So friction will be applied in this direction. So friction force will be present in this direction. So this is the friction, whatever is present here, that would be present in this direction. Okay, I hope you understood this. So friction, there should not be any relative motion between M1 and M2 as M1 wants to move forward. So M2 will be, the friction force will be trying to stop that M1. So that friction force is now pulling this M2 the forward direction so that they both will move together. I hope you understood. And there is also a friction present here which will try to stop M2 again. That means here the friction will be acting in this way. Okay, I hope you understood this. These are the various frictions that are present. So now let us take a question and let us do these type of problems. Okay. Let us do this question. In this, the two block question, whenever such questions come, you should solve them in 2 steps. Step one, we should always find whether the body is moving or not. Okay, this is what you should find out. Whether the body is moving or not. How will you find out? Find the limiting friction and check if it is limiting friction is greater than applied force, that means the body will not move, there is no acceleration. If the limiting friction is less than the applied force, that means the body is moving, and with whatever, then you can find out kinetic friction. In this case, limiting friction is equals to 0.6, yep, and 0.6 into normal, which is 100, which is equals to 60 Newton. But our applied force is 100 Newton, so the body is moving. So the body is moving, so we should use kinetic friction. The acceleration will be present. Then we have to go to step 2. In step 2, try to find out which body is moving with friction, is moving with only friction. This is what you should find out, which is moving with only friction. You have to find out a block which is moving only with friction. This 10 kg block is moving with 100 Newton force. Okay. And the block 40 kg is the block which is moving only due to friction. There is no applied force on it. Nobody's pushing it. Nobody's pulling it. It is moving only pure due to friction. Because of this contact that is present between them, it is moving. So we have to draw FBD for this. Then step 3, draw FBD for that 40 kg block. Draw FBD and find the maximum acceleration that the 40 kg block can have. So maximum acceleration that the block can have, find the maximum acceleration. That is the acceleration with which these both bodies will try to move. Okay. Now let us check all the steps. First, I know that it is 40 kg block that is moving. So let me draw an FBD for that 40 kg slab or block, whatever it is. Now this is my 40 kg. This 40 kg, let us draw FBD of this. Downward direction mg, downward direction normal reaction due to the block, upward direction normal reaction due to the floor, and there is a friction force which is present in this direction. Why I have put friction force in this direction? Why? Because in the above block, 10 kg block, friction will be present in this direction. Friction will be trying to stop that 10 kg block from moving. The same friction for the 40 kg block will be present in this direction. It will try to make that 40 kg block also to move along with that 10 kg block. Okay, that is what friction will do. Friction will always oppose relative motion. So which normal reaction I have to use? I cannot use this normal reaction because this friction is happening at this surface This surface means this normal reaction I have to use. How much is this normal reaction? This normal reaction you have to calculate from the block pump. Okay. So how much is the normal reaction? This normal reaction is equals to mg. So normal reaction due to the block is equals to how much? That is nothing but 10 into 9.8. That is 98. This normal reaction value is 98. This much is the force with which the block is applying on the 40 kg slab. So I will calculate the friction. Friction is equals to mu k into normal reaction. The kinetic friction is equals to mu value has been given as 0.4 and normal reaction is 98. This is what has been given. This friction is responsible for the block to move. So friction is equals to the friction, which is how much? Friction is equals to mass into acceleration. Why? Because this is the only force that is causing acceleration in this. This acceleration we can calculate. Maximum acceleration with which what it can move is 0.4 into 98. 0.4 into 98. Mass of the block is 40 Newton. Mass of the block is 40 Newton. So this is the maximum acceleration with which it can move. So if I take this 4 ones, 4 tens, acceleration would be equal to 98 by 100. That is 0.98 meter per second square. If the body moves with more than 0.98 meters per second square, then that blocks will move apart and the friction cannot hold them together. So the maximum acceleration of the slab would be 0.98 meters per second square. I hope you understand. This is how we will calculate the maximum acceleration in the block. Okay. Thank you.